Hello, and welcome to another session of Dell Networking. My name is Humair Ahmed, and I'm a Senior Technical Marketing Engineer at Dell. Today we're going to take a look at network virtualization with Dell Infrastructure and VMware NSX. I'll demo network virtualization with VMware NSX over a reliable, cost-effective, converged infrastructure. This presentation and demo will highlight a complete end-to-end converged Dell infrastructure, optimized, simplified, and robust underlay network, consolidated infrastructure to decrease cost, and flexibility and cost savings with speed of deployment, automation, and minimized downtime. The success of server virtualization over the last decade has now brought into the forefront the need to also virtualize the network or decouple the network services from the underlying physical infrastructure. Server virtualization decoupled the operating system from the underlying hardware. This provided flexibility in that it allowed us to move VMs from one server to another with no downtime. However, the VMs are still tied to the network services. For example, we could not move a VM on a server in Rack 1 to a server in Rack 2 unless the top of rack switch in Rack 2 had the same network configuration and services that the top of rack switch in Rack 1 had that were utilized or needed by that VM, such as the correct VLAN, ACLs, or any other security configurations. The same benefits that made server virtualization incredibly popular and successful is now also driving network virtualization as part of the software-defined data center. Some of these benefits include speed of deployment, flexibility, agility, automation, minimized downtime, and normalization of the underlying hardware. In this presentation, I'll review some of the reference architectures and deployment details of VMware NSX running on top of a complete Dell infrastructure. I'll also show a live demo of VMware NSX. There's two versions of NSX, NSX for vSphere only environments and NSX for multi-hypervisor environments. In this presentation and demo, we're going to focus only on NSX for vSphere environments. Dell networking hardware will provide the physical infrastructure and network underlay. vSphere ESXi will be the hypervisor installed on the physical servers. The NSX version will be vSphere only version, or NSX 6.0. The cloud management platform can be VMware vCloud Automation Center or any cloud management system leveraging the NSX REST API. The hardware NSX L2 gateway is currently only supported with NSX for multi-hypervisor environments. A hardware NSX L2 gateway, such as the Dell S6000 switch, allows for encapsulation and decapsulation of the VXLAN header within the ASIC in the hardware. For NSX-vSphere version, this encap-decap of the VXLAN header is done via a kernel-level module, allowing for close to line rate performance. Before we jump into the demo, let's take a brief look at the NSX components. As mentioned prior, the physical underlay is composed of Dell networking switches. The data plane is composed of the ESXi host with the virtual distributed switch with kernel-level modules installed. How this works is the NSX Manager is installed first as a virtual appliance on an ESXi host. Once installed, we can access the GUI via web browser and link it to a vCenter server via the vCenter IP address. The NSX Manager plugin is then automatically installed into vCenter and can be accessed via the vSphere web client. Next, the NSX Manager plugin can be used from the web client to install the kernel-level modules like VXLAN, Distributed Logical Router, and Distributed Firewall into the VDS and onto each host. A NSX control cluster of at least 3 controller virtual appliances compose the control plane. The controllers are also installed via the NSX Manager plugin. With 3 controllers, the loss of one controller will still allow the control plane to function without issue. Even if the entire control cluster is lost, data will keep forwarding because data never forwards to the controllers. However, network updates can't be made until at least one controller comes back online. The NSX Manager and control cluster both sit on the management network. As mentioned prior, the NSX Manager is a virtual appliance that sits on the management network. From the NSX Manager, all the other components of the virtual environment can be installed. The NSX Manager also exposes the NSX REST API, which can be used by a cloud management platform to simplify management. Please see the Network Virtualization with Dell Infrastructure and VMware NSX reference architecture document, for more details on Dell networking underlay topologies. In this demo topology, I have a completely converged architecture with the L2 underlay leveraging data center bridging and providing a lossless Ethernet fabric. The Dell MXL blade switches act as top-of-rack or access switches for blade servers, while the Dell S4810s act as top-of-rack for the rack servers. Virtual link trunking or Dell's VLT technology is used to provide active-active links and multipathing from the MXLs and the S4810s to the core or spine S6000 switches. VMware active-active teaming options are used from each ESXi host to the top-of-rack or access switch. A few infrastructure VLANs are still needed for management, storage, vMotion, VXLAN or transport, and edge traffic. The gateway for these infrastructure VLANs can be provided via VRP or proxy ARP in order to achieve gateway redundancy or high availability. In this setup, the gateways are implemented on the Dell S6000 spine switches via proxy ARP. All servers have two 10-gig ports carrying converged traffic. Data center bridging provides for a lossless Ethernet fabric with pause per priority or class of service. The Dell EqualLogic iSCSI array supports DCB and is attached centrally to the S6000 spine switches. In this setup, you can see there's a separate compute, management, and edge cluster, each with their own respective VDS switch. This is not a requirement but was implemented this way, so only the required configuration or NSX components are installed on each host. NSX components are installed at the cluster and VDS level. So for example, VXLAN is configured at the VDS level and defines a transport VLAN for the VXLAN traffic. However, none of these management hosts need to have the VXLAN configuration or transport VLAN. For this reason and other similar examples, I chose to implement a separate cluster and VDS switch for compute, management, and edge. This management cluster here is composed of 4 rack servers. There are 3 NSX controllers and each controller resides on a different physical server. This management cluster is also where I have the vCenter Virtual Appliance, NSX Manager Virtual Appliance, and my DNS server. There are 2 edge servers in the edge cluster for high availability, and this is where the edge appliances like the Perimeter Edge and DLR Control VM, which I'll discuss in more detail during the demo, reside. So with that, let's go ahead and jump to the demo. First thing I'm going to do is go to my NSX Manager and hook into the vCenter. First thing I gotta do is come to this Manager vCenter registration. Now remember, this is just a virtual appliance I installed on my ESXi host in my management cluster. So I come here to the Manage vCenter registration, and you can see I've already set this up, but you just put your IP address here where it says vCenter server. It links to your vCenter server. It's a one-to-one relationship, and then the NSX Manager plugin gets installed on that vCenter. That's the most critical aspect here, so let's go ahead and just jump to, there's some other things in here you can look at. For example, here you can set up an NTP server, a syslog server, and some other features here, but I'm just going to go ahead and skip right to the NSX web client and access the vCenter so we can see the NSX Manager plugin. Okay, so here this network and security tab, this is new. This was not there before, or this isn't there traditionally in vCenter, right? So this is the NSX Manager plugin. Now before we jump to that, let me just show you real quick the hosts and clusters. So here's my, just like in my diagram, here's my edge cluster, management cluster, and this production site A and production site B are basically my compute clusters. I just made 2 separate clusters to show that I can create logical switches over more than one cluster. And if I look at my VDS switches, you'll see again, just like the diagram, I have a separate VDS switch for compute, edge, and management. Now, if you look at my compute VDS, you can see I have those infrastructure VLANs I mentioned before. VLAN 201 for my storage, VLAN 401 for my transport or VXLAN, VLAN 301 for my vMotion, and then all these virtual wires here are actually logical switches that have been created. And I'll explain that in more detail later. But here I have two storage port groups because I'm multipathing. Remember, I have two 10 gig ports shown here. So I have a separate port group. Each one is linked to a separate uplink. So it's multipathing over those two 10 gig ports for my iSCSI traffic. So with that, let me go ahead and go back to the Network and Security tab. Now, we've already linked the NSX Manager to the vCenter and installed the plugin that way, right? So that's what we're seeing here. So now, the next thing I would need to do is go to my installation here, go under Management, and this is where I would install the controllers. And you can see I've already installed 3 controllers here, and again, each controller is on a separate server in that management cluster, sitting on the management network. You can see here you can just click plus and add another controller. But I've already installed 3 here. So once you've installed the controllers, the next thing you do is go to the Host Preparation tab. And in the Host Preparation tab, this is where you're going to install those NSX bits, like the distributed logical router, the VXLAN, the distributed firewall, those kernel level modules within the VDS. So again, as I mentioned earlier, you install the NSX components at the cluster level here. And you can see here it's already been installed, the bits have been installed, and the firewall here is enabled. Distributed firewall has been installed, and the VXLAN bits have also been installed. And you can see I've not installed that on the management cluster. As I mentioned before, my management hosts do not need any VXLAN modules or any NSX components because it's just my NSX manager, my vCenter, and the controllers. They're not going to be part of any logical switches or need any of that VXLAN configuration. So next I go to my logical network preparation, and now I have to set up what's called a transport zone. The transport zone basically defines the boundaries of your logical switch. So a logical switch can never span on a host that's not part of the transport zone. So what I would do here is just click plus, and I would select all the clusters I want to be part of that transport zone. I would name my transport zone, and then I would select the control plane mode. I won't go into the control plane mode details here, but you can check out the white paper, the Dell VMware NSX reference architecture white paper on Dell.com and on VMware.com, where I explain more of the multicast, unicast, and hybrid control plane modes. But basically, VXLAN, the VXLAN protocol required, even before NSX, required multicast on the physical network. So you still have that mode here available, multicast mode, but you can also use what's called unicast mode. And what happens in unicast mode is it takes away that requirement to have multicast on your physical network. So basically the BUM traffic, or broadcast unknown unicast or multicast traffic, is replicated by the host. So the host sending out the BUM traffic replicates that broadcast unknown unicast or multicast traffic, and it knows what other hosts are part of that logical switch. So it'll unicast out to the respective hosts that are part of that logical switch that need to receive that traffic. So with this proprietary kind of implementation, actually a very smart way of doing it that VMware has done, they've taken away that extra requirement that you need that multicast implemented on your physical underlay switches. So in unicast mode, you no longer have that requirement where you need multicast enabled on the physical underlay switches. Okay, so we're going to go ahead and cancel. and because I've already set that up here. So once all of that is done, you can actually go ahead and start creating your logical switches. So here you can see I've already created 5 logical switches, and now would be probably a good time to show you the logical design. I've shown you the physical design here. Let me show you what the logical design looks like. So this is the logical design of my network. So here's the 5 logical switches I just showed. 1, 2, 3, 4, 5. They're identified by what's called a VNI, or a virtual network identifier. So let me show you how that logical switch is actually created. So all you have to do is come here, hit the plus sign, and you basically just type in the name of the logical switch and select the transport zone. We already created this transport zone, and click OK, and it creates another logical switch. And then you can add VMs to that logical switch just by clicking this, actually not that, but this symbol right here, add virtual machine. And if I click on the web tier and even some of these other tiers, you can already see there's some virtual machines attached there. Here, for example, you see the web VM. Now, whenever you create a logical switch, as I showed here, there's 5 logical switches. When you create a logical switch, what's actually happening behind the scene is you're creating a port group. So if I go back to my VDS switch, I can actually show you the port groups that are created. So I'll go to my compute cluster. And remember I showed you those logical wires before. So I created 5 logical switches, so you should see 5 logical wires. So as I scroll down here, you can see 1, 2, 3, 4, 5. Exactly 5 logical wires, each representing a different logical switch or logical network. And you can see in some of these I've already added VMs to some of the logical switches. So once I add a VM to the logical switch, I'm basically abstracting away or decoupling the VM from the underlying hardware. It's no longer attached to network services on the physical network. Now you're attaching the VM to network services on the logical network because you're connecting the VM to the logical switch. Now, going back to my Network and Security tab, I can also look at the NSX Edge appliances that I've installed. So here I have a perimeter edge or perimeter gateway, also known as the NSX Services Gateway. And here it's residing on one of my edge servers, right? I mentioned I have 2 edge servers here. And the perimeter edge gateway resides on the edge server, but you can install it in high availability mode, where it'll install an active and standby perimeter edge. If one fails, it'll fail over to the other one. In NSX 6.1, they'll actually have the ability to do active-active. Right now in 6.0 it's active standby, so you can still have 2 edge servers for high availability, and you'll install one active perimeter edge on one server and a standby on the other. In 6.1 you'll be able to do active. And it also has what's called the distributed logical control VM, which is also installed in the same way, active standby, and if it fails over to the other one for high availability. So your perimeter edge or NSX services gateway peers with your external networks and communicates those external networks to your DLR control VM via the transit network. And this transit network is just the logical switch we have set up. So it peers with the external network and also peers with the DLR. The DLR control VM learns the external networks and then pushes that down to the kernel level modules, the DLR kernel level modules. So you can think of the DLR control VM as basically a management VM for those kernel level modules. Okay, the DLR control VM is also where the L2 bridge functionality can be configured. So you go to the DLR control VM and configure your L2 bridge to allow for bridging between logical networks and physical networks. So here's a physical server here on VLAN 31, so I can actually bridge between one of the logical networks and physical networks using the L2 bridge functionality, which is also implemented within the kernel module, but you actually configure it and set it up through the DLR control VM. The perimeter edge also has these edge capabilities such as edge firewall, NATing, VPN, those network services that you would expect at the edge. But a main thing to recognize here is that the perimeter edge is a VM, whereas the DLR is a kernel level module. So the DLR is providing routing at the within the kernel. So for example, if I want to route between my web tier and my app tier, I never even have to leave the host. It comes up to the kernel level module and it routes to the app tier or the DB tier. I can also connect it to my perimeter edge instead of the DLR, but then it would go all the way out to my edge server. The edge server will have a VM sitting there. It's not a kernel level module, and then it will route it to my other logical switch. So with that, let's go ahead and head back over to the vSphere web client. And you can see I'm in the perimeter edge or perimeter or NSX services gateway. So here's the firewall, DHCP, NAT, routing, load balancer, VPN. Again, those network services that you would expect at the edge. And this is actually the distributed router, logical router control VM. If I go in here, you can see here I can also configure the distributed firewall, the distributed routing, and also the L2 bridging functionality that I was mentioning. Here you can see I've set up a L2 bridge. If I go to my diagram, it's right here. So I've actually bridged this VLAN 31 with one of the other logical switches, this bridged app tier, so that this VM on this bridged app tier can communicate to my physical switch. So if I go here and I just click edit, you can see I selected a logical switch, bridged app tier, and I'm saying bridge it to my distributed virtual port group, bridge edge, which is basically that port group has VLAN 31 assigned to it. VLAN 31 because I'm communicating to this host on VLAN 31. So with that, let's go ahead and go back to the vSphere web client and do an interesting demo. First thing I want to do is go to my perimeter edge and delete one of the firewall rules I had put in earlier. Okay, and this is how easy it is to delete the firewall rule. You just select it, click X, and then hit publish. And what I want to do in this demo is I'm going to console onto my VM on this web logical switch, which is on a subnet 172.16.1, and I want to ping my app VM on the app logical switch. So what's going to happen is it's going to go up to this DLR, stay within the host, and this DLR kernel level module is going to route it to my app tier. So let's go ahead and see that work. I'll go on my web tier, look at my virtual machines, and console into this guy. Okay. So again, I'm on, this guy has a IP of 172.16.1.1. I'm going to ping 172.16.2.1, which is the app VM. And we can see we can reach it via the DLR. Now, if we do a trace route on that, we should see only a one hop because it's a distributed logical router, so we should only see one hop away. So let's give that a shot and see if we get what we expect. And there it is. Again, it is what we expected. Because it's a distributed logical router, we only expect to get a one hop on a trace route, right? So it's just going to go from the web VM to the distributed logical router to the app logical switch in the app VM. So now what we're going to do is I've actually gone ahead and I'll already moved this web VM or this web logical switch to the perimeter edge. So I had it connected to the distributed logical router before. I've disconnected it and now I've connected it to the perimeter edge. So by connecting it to the perimeter edge, now I have all these external networks that can access my web VM, and what I'm going to do is create a firewall on my perimeter edge so I can no longer ping between my web and app VM, just to show how I can create kind of a mini DMZ kind of thing. So here I'm going to go to my perimeter edge. And what I want to do is access the firewall. And you can see how diverse the options are. For the source, I'm going to select the logical switch. Basically, I'm saying traffic from this logical switch, which is the web logical switch, as the source, and for the destination I'm going to select the app logical switch. So I'm basically saying block traffic from the web logical switch to the app logical switch. I just have to come here and select deny, and then publish that rule. Now you saw we were just able to ping the app VM from the web VM using the distributed logical router. And then now what we did is we simply moved the web logical switch to the perimeter edge, and now we're going to use the perimeter edge firewall to block the web VM from communicating to the app VM. And we can see this rule is now published. So we should no longer be able to ping that VM, and you can see indeed we cannot. Now I can just simply come back here and delete it and then publish that, and again I should be able to ping it. If I go back and look at my logical network diagram, as I mentioned before, my perimeter edge is peering with my external networks, so I should be learning the 180, 190, and 200 networks. Let's go to my perimeter edge VM and confirm that I'm actually learning those networks. So I'm going to go back out to hosts and clusters, and I'm going to go under the edge cluster, and there's my perimeter edge VM. So I'm just going to go ahead and console in. And the syntax is going to be very similar to what you're seeing on a standard switch or router. Show IP route OSPF. And as you can see, I am learning those 180, 190, and 200 networks. So that's it for this presentation and demo. I hope it's been informative for you, and for more info, don't forget to check out the Dell and VMware NSX reference architectures on Dell.com.